Okay, so before we dive into the demo, I just wanted to give a quick overview of the tool and platform that we're going to be using for the demo. And that's RocketML's homegrown distributed deep learning solution called RML-DNN. And what that is, although it is a standalone tool for distributed deep learning, RML-DNN is offered as part of a much bigger stack of cloud integrated solutions, like the one depicted here on the right-hand side. So the stack starts off at the bottom layer with a cloud orchestrator component, and that's the piece that interacts with the underlying hardware, the VMs of the cloud and whatnot, and takes care of tasks like cluster management, allowing the user to spin up a cluster, add machines, draining the cluster, all at the push of a few buttons at a much higher level GUI interface. And on top of this layer sits the HPC backend layer. And that's where things like RML-DNN and other software accelerators would live. But the user doesn't directly interact with these. There's then this DevOps layer where a powerful and in general graphical user interface exists to allow interaction with the underlying layers. And on top of which, then this research workbench layer exists. And that's where things like spinning a Jupyter notebook and using high-level libraries like TensorFlow and PyTorch, that's where the user would do those things, all at the same time that taking advantage through the stack of the low-level HPC components underneath. Going back to RML-DNN quickly, it is a standalone tool for distributed deep learning, like I said, that implements the data parallel DDL design or strategy, like we discussed before. It is the whole thing is cluster agnostic, so all this works seamlessly on CPUs and GPUs with pretty much no code change to the user, and all at the same time that it takes advantage of low-level, tried-and-true HPC libraries like MKL, MPI, etc. And finally, RML-DNN usage is based on the principle of code minimalism. So the amount of code needed to run it is actually very small. And this is actually a real example of what you'd need to do, how much you'd need to code to train DiffNet, to train a neural network to solve the Poisson 3D PDE like we've seen before, right? So you just have to build this dictionary of configuration where things like batch sizes and input paths to your input data set and test data set would be defined. You specify what optimizer you want to use during training, the learning rate, the number of epochs, and things like that. Then you instantiate an RML model object, passing your network file, and this is happens to be a Keras compatible network file, just the same kind of JSON network description that you get out of Keras. And you call setup on this object by passing the configuration dictionary you created above, and that's it. Then you just call execute on the RML model instance, passing things like how many nodes you want to run this on, how many tasks or processes per node you want to have, if it's going to use GPUs or not. That's as much as it needs to know in terms of is it GPU or CPU, and that's it. The whole interaction with the cluster management system, launching the job, monitoring the job, is all done behind the scenes by the stack that I discussed before.